Hello everyone, and welcome to our quick lesson on arcs. And so remember that arcs, we talk about like whenever you shoot a basketball, you arc it, and so that it will go into the hoop. And so arcs are going to be like the crust of a pizza. So whenever we have a circle, we have a piece of the circumference, and it is called an arc. Okay, and so it is going to have both endpoints on the outside of the circle, and it's going to be a curved piece, okay, a curved piece of the circle. So the first thing I want to look at is whenever we're looking at a full arc, we're going to talk about the how many degrees the arc is. And so when I'm looking at this very first one, it is a full circle. This one goes all the way around, and so that is going to be 360 degrees. Okay, that is going to be 360. Whereas on the next picture, we have a diameter drawn in. How do I know that it's a diameter? Because it goes, it's a chord that has both endpoints on the circle, and it goes through the center as well. So since that is a diameter, I know that this is going to be 180 degrees. Okay, so the first one all the way around the circle is 360 degrees. Halfway around the circle is going to be 180 degrees. Okay, so now how do we find the value of z in this next picture? Well, again, I have a diameter. How do I know that it's a diameter? Because it is a chord that starts and stops on the circle and goes through the center. So what do I know that the sum of these two should be? It's going to be 180 degrees total. And so what you would do is you would do 4z plus 2z. It's going to be equal to 180. So we're looking at the measure of these arcs and not the length of these arcs. We'll come back and do length of these arcs later. So let me see if I can fit that. Equals 180. And then 6z has a value of 180. So you're going to divide by 6 on both sides, and we should get 30. Okay, so what is our value of z? Our value of z would be 30. How do I know that that is correct? If you did 4 times 30, you'd get 120. So this would be 120 degrees. And then if you did 2 times 30, you'd get 60. 120 plus 60 is, in fact, 180. Okay, so that is the measure of that full thing is 180. The value of z is 30. Okay, but there's a theorem that says if you have congruent arcs, you have congruent chords. And if the chords are congruent, then the arcs are congruent. So it's true both ways. So on this very first picture, this is an example where we have congruent arcs. These arcs match. This arc is arced 100. This arc is 100. So what does that mean about the chords? You could see if you were to fold it along this center, you fold the circle along the center, those would fold on top of each other. And so those chords are going to be congruent as well. So 2x should be equal to 50. Those chords should be equal. And so we divide by 2 on both sides, and we'd get that x is 25. So x must be 25, because if x is 25, then both of those chords have a length of 50. But the reverse is also true. If you have congruent chords, which these are marked as congruent, this red chord is marked as congruent to this red chord. Since those chords are congruent, equal in length, that means that the arcs that get created with them are going to be congruent as well. So if this arc is 121 degrees, if that's what it measures, then the value of C is also going to be 121 degrees. So congruent chords have congruent arcs have congruent chords. That's our major takeaway and our little mini quick lesson on arcs. We'll do more of that next week.